it's about ITMA 2023, which happened on 8th June to 14th June. And it's a very big fair. And it's just, I can say, for anyone to impossible to visit all the stores and anything. We try to cover it just in our eyes point of view, what is our need based on our need. Just a brief for the audience that ITMA started in 1951, and usually it happens only in the limited 4 or 5 countries which is circulating. And in the 2023, there was almost 1,009 exhibitors from the 47 countries. So, and the visitors who gone there, that was a 1 lakh, more than 1 lakh visitors visited in the seminar, in the fair. Basically, the theme of this ITMA was creativity and innovations, a bridge towards sustainability. And in the direction of that, if we see the visitors and the exhibitors, most of the exhibitors, they gone with the QR code system for their leaflets. So it was very easy for us, like the travelers. With this time, we have not carried too much bags on the air and during traveling time with the leaflets and all these things. It was just QR code scan, you get information. So we were taking photos of the QR codes only for the machine details. Circular recycle of the textile. That was a lot of innovation has happened in that direction, sir. And in that line, we are coming with the in ITMA that post-consumer waste also being used and pre-consumer waste also being used. See, post-consumer waste, if we see in other way, it's being in our Indian culture. We generally don't throw the textile, our fabrics, cloths easily. We use till the last it stands. We can use in our household to clean the thing, anything, and then till the time is existing. And that was a good culture. Slowly that vanished. So now the culture is coming to reuse the same textile, all the garments for making a new things. So it's become a circular textile value chain. See, suppose garment is there. So garment has to be recycled again to the fiber, again to the yarn to fabric to the, again, garments. So in this direction, lot of machine manufacturers come, and it's being the spinning technology, which they are dividing the cotton into the fibers, the garment into the fibers, and then reusing. In the same line, we have gone there, come up with the plastic cheese also. See, in the yarn dyeing, we are using a plastic cheese. So plastic cheese, reusable plastic cheese, we are seeing a long time, sir. But the plastic cheese was made from the glass fibers. So when we dye multiple times, the glass fiber is coming out on the surface. The operators who is using the this plastic cheese, they feel the inching in their hand. So that was a major concern for the operator side. Now in this, some plastic cheese has come where we will dye the yarn in that. After that, this plastic cheese can be returned to the supplier, and they will remanufacture again it. So it's being recycled of the plastic cheese itself. In the if we go for the soft winding and rewinding side, the SSM has come. SSM, this machine manufacturer company, they have come up with a beautiful idea where in the same machine, where any type of soft package can be made. The filament also can be made, spun also can be made. The same machine can be used for the rewinding also. Because generally for the rewinding, we have to give a conical shape, all those things. So we were having a different winding machine, different rewinding machines, different. But SSM has come with a new YW package winder, which can be used as a soft winder also, as a rewinder also. So at the investor point of view, it's an advantage. We need not to purchase the 2 machines. In the knitting side, when I find a very good machine one, where generally we have all the knitting machines of 1 gauge. It is a 10 gauge or 24 gauge or 32 gauge, any gauge, but the gauge is the one for the cylinder and dial both. one of the machine supplier has come up with the two gauge. Cylinder is different gauge and the dial is different gauge. So the advantage of that was one side we are getting a thick fabric, one side we are getting a very fine fabric. That's a really beautiful fabric. And I believe that's going to be the future fashion trend in the market. In the same way, the Meminger has come. See, basically, when we are feeding a lycra, the elastin yarn in the knitted fabric, we are not able to control the tension properly. So we don't know how much the lycra tension is going on, especially in the flat knitting. With this is drive is the negative drives. So Meminger has come with the new devices where they can control the feeding tensions also of the lycra in the flat knitting also and in the circle knitting also. This is the type of the game of the equipment where the lycra is passing through, and we can check the online how much the tension is going to the yarn. This device can be used for the lycra and non-lycra, any type of fibers. In the same line, when the Meminger has come with a new one technology, see the loop length adjustment is a basic crux of the knitting machines of making a good fabric. We say to the fitter, okay, you set 2.75 loop length. This is now the skill of the fitter. He's setting 2.75 or 2.73 or 2.78. But now it has become a digitized. If we feed a 2.75, automatically all the pulley element has been made by the 2.75 knitting loop length. So the belt life also will improve. That becomes a completely automatic drives. And in the fleece machines where we are making a filament fleece, the three fiber we are using, three yarn we are using. One top is the cotton, in between the filament bag is the PC. Generally, as a knitter and dyer we face, the filament portion is coming out. So that gives the stains effect type of the Milan type of looks. It doesn't look good. So now the Milan has come with the good machines where they can set the filament tensions properly, and the chances of the coming of the polished filament out is a very rare. This I find as a solution. See, in a niche fabric, whenever we are making any tubular knitting machines, we generally face a edge line problem, mainly in the single jersey, PK, on dot fabrics. So we say the last gutka has been removed or not. People are removing, even though we are saying the problem is persistent. So again, the MyNC has come with a new solution. They just tapered the last gutka. For the productivity side, I seen one machine of the pylon. They have come with the speed factor 2200. Usually we have a speed factor of the 900 to 1200. So it's a very high speed machine and high leg machine. Now, as the theme was a recycling and the controlling production and all quality controls. In that, the one new technology I seen is a Nithon. Basically, what it does, it is detecting a knitting defect exactly at the knitting point. Again, this technology was driven by the MyNISTI. So generally, we have so many scanners for the knitting purpose, but they scans after knitting. So the defect already has been created. 1 meter fabric has been produced. Here, the machine is detecting a defect exactly during knitting time. So that quantity will not be defective. Produced will not be defective. They given a name, the knit hack, this technology. And they made a logbook type of online logbook where all the defects can be recorded. Any defects which is not visible by the eyes also. Generally, we see the lycra breaks, which is difficult to detect by the operators. That's also been detected by the machines. And in the printing side, digital printing is coming up in a new way, is already running. Digital printing has its own challenges there. So now Epson has come with the some more modification. The machines, their application also can, the preparation application also possible in the digital printing machine itself. ColorJet also has come with the digital printing machines, and they were the partners of the ITMA. And Jimmers has come with the screen stripping machine. Basically, we are using a rotary screens. So in that, we are stripping a machine screen. The stripping generally people use with the chemicals. Now the people has come with the water jet stripping machines. In the same way, the Jimmers has come with the water jet stripping machine. But the advantage here is they have only one nozzle. If you see the Nova Jet, which is the commonly used stripping machines, that has almost 25 nozzles. Here, they have only one nozzle. So the maintenance of the machine is better. The pump which is being used here to insert the water, that's also a very high capacity. So what they given a name, they are giving a name of the ironing also. It's a gimmick of the things, but basically that what they are trying to prove with this, there's no dent in the screen even after stripping. That was the few of the things. In fact, I also seen one there. We put one screen there and it stripped there completely. There was no dent. And the E+L has come with the EL clean model. EL clean is what? Basically, when we are doing in printing, lot of time the fluff comes, the bio polish. We do the bio polish to the fabric. Loose fiber is always in the fabric. So they have come with a beautiful idea of the sections just from top and bottom both. And that suction is very powerful. They have put the compressor very hot, capacity high. So it sucks the very fine dust also. And it was able, I think it's able to good solution provider for a digital printing, very small, just can choke the nozzles. If we coming to the dyeing side, see, soft flow machines are coming with the low liquor ratio and low salt, less salt, all those things happening. When we are seeing the CPB side, cold pad batch dyeing side, there the laboratory is struggling to weigh the exact quantity of the dyes, because here we are measuring in the gram per liter, GPL. People use the liquid solution for the light state, then they convert to the grams and all these things. In this case, I find a Lloyd has come with the beautiful system that's only for powder. The 24 powders can be kept there. They weigh accurately. It can be dissolved, can be mixed with alkali together, and can be weighted together. And Madhubatech, as we all know, it is working for the this bleaching range and the finishing range and dyeing, continuous dyeing range. So they have a cold pad based dyeing technology. It's running since long. And in that quantity, they have come up with the pad steam dyeing for the knit fabric. This is a really good technology. In fact, I also purchased this machine in JJ. So here is a padding, steaming within 3 minutes, and then washing continuously. So within the 1 hour, we get the finished fabric, dyed fabric, which is the fastest. Usually, this technology was used for the woven fabric, pad steam, pad dyeing, or e-control, all those things. In this technology was missing. So Albatech has come with the new technology. They've given a name, rapid dyeing, the pad steam in this. E+L pick counter. Basically, in the finishing, when we talk about the finishing of the fabric, we say the EPI, PPI, or the courses weights are very important to control the physical parameter of the fabric. Till date, the system was to controlling the ends per inch or courses per inch. Now they have come with a beautiful solution. They are controlling a GSM. Basically, in the knits industry, people don't go by the CPI WPI. People go by the GSM. I need a 180 GSM fabric. I need a 160 GSM fabric. So they are saying you cut the GSM, you put in the GSM weighing scale. They will count the CPI WPI accordingly. And now they're coming a reverse correction. To get this GSM, I have to get this much CPI, and machine is adjusting CPI as per that. And online, we are recording the GSM of the running fabric. Baldwin has come with the spray technology, a chemical spray technology. This can be used for the softener. This can be used for the any type of finishes. This can be used for the coating of the fabrics. Here, basically, they are trying to spray through the set of the nozzles on the fabric. So the softener which we are applying on the fabric is not getting raised. Generally, we apply softener to the paddle where a lot of water exchange happens. So the strength goes down. The consistency is not coming. I believe this is a good technology. I'm also doing trial on this. Uh, compactor. Compactor is the last process for the finishing knits fabric finishing, where we control the shrinkage, we control the smoothness of the fabric. And now, actually, if we talk about last 5 years, the demand is changing in the buyer side. Earlier, they were accepting 5x5 shrinkage in the single sheet type of fabric, 7x7 in the rib or interlock. Now they need everything 3x3 shrinkage. That's becoming a biggest challenge for the processing side. People are doing the panel wash, people are doing the garment wash to control the shrinkage as per that. In that line, I find the Laffer has come up with a good solution where they have used the shoe technology with the felt technology combined. And here, the felt technology, they kept a very big cylinder, 550 mm, so the fabric will be get stabilized there. And I have seen the test report of that. They are getting a 2% shrinkage on the honeycomb type of fabrics, where before shrinkage was 10%. I'm also doing a trial on this fabric. Initial trial gives a very good result. Even in the interlock, I got a 4% shrinkage in that fabric. And the same line, the people are going with the different options. See, 2015-16, people thought about to using the rubber technology in the knit compression also. As like 0 type of finish, 0 we do in the woven fabric. In the knits, that technology was missing. So number of suppliers came with the rubber technology in line with the felt technology, the compression. In that technology, the problem was, still problem persists. We have to use the water to cool the rubber. And the rubber, the life is hardly 1 year. Every year we have to change the felt. That's a costly affair. So in that line, this time I seen the Syntec and one more supplier. And the Syntec has come and the Ferro has come. They have made the rubber with a very thinner rubber, which doesn't need to cool it with the water. And they have kept it as a secret because they have not sold, started the marketing. And only they are showing the fabric which has come out from the compactor. It looks hand feel is very soft. We need to see the durability of this machine. Lint cleaning. Basically, the lint is the fly, loose fly that comes in the stanter, dryer, all those machines. And the drying efficiency depends on the cleaning efficiency of the operator. So now a lot of the machines has come with the automatic lint cleaning. We also using automatic lint cleaning, but we face the problem of this lint cleaner belt moves very fast here and there. It was getting damaged very frequently. So I spoken to a number of guys there. They given solutions, and it looks that this is worth because this will improve the efficiency of the dryers. So it's automatically cleaning the lint. That's there. Now, actually, the Mathis has come with the new solutions. They have come with the smart liquor dye bath analysis system. Actually, this is the pain area of the dyers. We as a dyer, we don't know which 3 dyes we should use. We should use all the 3 dyes which is getting exhausted together or not. So to check that actually what is happening inside the dyeing machine, Mathis has come with the smart liquor dye analysis system. They fix this equipment. They check the color value. They check the exhaustion value, the conductivity. They check the pH online. And with that, they find out which dye is going faster, which dye is going slower. with the help of this, the dyer can decide how much time I should give for the exhaustion, how much time I should give for the fixation, how much time I should go for the soaping. They have conducted a trial. I have seen that trial. It's a really worth. Now coming to the inspection side. See, basically, when the fabric is being produced, the inspection system is manually based. Now, a lot of machines has come, machine supply has come for the online inspection. They detect the online fault. It was very good working for the solid fabric, the plain dyed fabric. But the system was not available for the yarn dyed or for the print. This time, the Shelton has used the AI system of the online detection of the print defects and the yarn dyed defects. What they do, they just see the first 1 meter of the fabric, that they make the negative image of that. It means they are removing the screen, the design from the fabric. The fabric become completely black in the computer side, in the camera side. Now they are checking a black fabric. If any defect is coming, then that's become a defect. That is not matching with the geometrical drawing. So it's a very good idea, and this will be useful for the detecting of the printed defect at the printing machine itself. Embroidery thread drawing. This is a really I think good idea. Person has, the color reel is the manufacturer. They've come up with the idea dyeing the yarn during embroidery itself. So they have a color injectors, and the yarn is the gray white yarn. No need to use the colored yarn purchase. Whichever yarn you want to use the colored, you can inject it during embroidery itself. So the inventory, you need not to purchase the colored yarn, all those things. And coming to ERP side, because now the industries are going big, so everyone wants the ERP controlled. Lot of ERP solutions has come. They have made a virtual dye house type of things, where in a plant sitting in the office, we can see what is happening in the machines, which machine, which trolley has moved, or how long the trolley not moved. All those things we can track back from the ERP systems. So virtual dye house, they have created the ERP. AI is being used in this to detect what is happening in the plant. Packaging. In the packaging area, see, generally we are using polythene. We are using a stretch wrap polythene to pack the, say, suppose the yarn pallet is there. To pack that, we have a stretch wrap polythene. Now the stretch wrap paper has come. It's a reusable paper, which is a stretchable paper. So packing of the has become a change. Design and innovation side, see, basically, ultimately, we have to make a garment, and garment has to be seen by the brand. There's a lot of time. We need to make a fiber similar. We need to make a fabric. Then we have to dye. Then we have to make a pattern. Then we have to show the garment. Now, with the 3D studio style studios, we can give the similar feeling to the buyer, the brands on the screen itself. So this type of fabric we are using, how much will be the stretch, how the color will be visible. So the color story, all those things can be decided quickly than the previous times. If to do this, we are doing a textile. Basically, each fabric is being textilized in the computer. So it gives a structural feeling. Same thing into the consumers also, the brand basically. LED light cabinet side. Now, basically, the very wide has come with the virtual light box. Virtual light box means if you take a photo, and this is a normal camera type, they take the photo, and how it will be visible in the LED light, how it will be visible in the D35 light, how it will be in the CWF light, that we can see in the virtual way. There's a one good thing. I don't know how much is success or not. I see hand feel is the virtually is a always the area. Someone will say hand feel is good, someone will say hand feel is not good. And that becomes a debatable issue between the brand and the consumers and the suppliers. A lot of time the finisher do the reprocess because someone says hand feel is not good. So we have to refinish the fabric. So to digitize the hand feel, the Atlas also has come with the equipment which can measure the hand feel. We need to see the usability of this. And there's one more company has come with the hand feel tech measure and the digitizing. It means people are thinking to digitize everything. This is basically the tools of the AI. And I find this time lot of startups company were there in the ITMA. And one of the startup company I met, the guy is working since last 10 years on this for this project. There is digital passport for the garment. Digital passport, word looks fantastic. Basically, what he's trying to do,
आप
he's
लोगे
trying to make a
सुशीला चाय लोगी
life of the garment and record everything in the system. Who has made the fiber, who has made the yarn, who has made the fabric, who has made the garment. After selling also, who is consuming. If suppose we want to resell, then the track, who has purchased, who has resell. So all those things being recorded in the system. And it's completely recycling of the product. This can be used for anything, not only for garment. The best part is the authenticity of the garment. See, actually, generally we say that some branded shoes or branded garments are available in the market. We don't know it's a real that brand or doesn't not. So there's a tag, just scan it. It will be tell you it's a real authentic that brand garment or not, because it's a high value items. So completely recycling of the traceability of the garment, who has made, who has reused, whether after wearing a garment, someone wants to throw it out, resell the garments or resell the project, that's also being recorded here. Natural dyes. I see this time two company has come for the natural dyeing also. The Dana has come with the natural dyes, and one more company, Maldana, has come with the natural dyes. Generally, we struggle to get a natural dyes manufacturers. So there are two manufacturers which I find they are supplying with the natural dyes. And these are the colors I taken a photo there from how they are making and all these things. I find the nano dye tech process also. Basically, the catenizing. So they are applying this nano technology in the pattern, further dyeing with the reactive dyes and immediately washing. So exhaustion rate is very high, almost 98% dyes is being exhausted. So very less load on the ETP side. Some new fiber tech development also happened where they are using leaves and stems to make reusable fibers. I find this very good thing, sir. The Antex is an eco-friendly, low-carbon footprint solution method. So this can be applied on the cotton, natural fiber also, and the synthetic fiber also. So it's the most sustainable. That's what I heard about them. We need to see how the feasibility of the things, and that's what they claim. The Higg index is the nylon and polyester 5-6 only. So colorant is 100% color is being exhausted. The water is consumed is very less. It can be applied to the transfer printing method on the fabric. Any type of fiber they claim it can be used. Any type of garment can be made. That's the technology machine which they are. I just taken a video from them. And in India, now the agencies are available for this technology. Denim effect can be given directly on the fabric. this looks to be really good. So these are some of their features of this project, how it can be used effectively. That's all. So in 2027, the net is going to be there.
Thank you, Shailendra ji. Wow, I must say this was a short virtual tour of ITMA for all of us who could not go there. But through your eyes and through your presentation, we really got such an in-depth tour of all the machineries which are going to be the ones in coming up in the future. Thank you so much for that. And on a short note, I must say that we must be able to contribute to his visit because he's given us such a peek into what is happening at ITMA. The next 4 years are for all of us to wait for, and I hope we will have a lot more things happening from India in that place. Thank you so much, Shailendra ji. There are many questions for you, but I'm going to bring that up after Mr. Misra finishes. So yes. Kamal ji, may I invite you for your presentation?
Thank you, Dr. Sao, and thank you all the viewers to be here to try and go through what I have in mind, I wish to share. Well, ITMA, like all the ITMAs, has always been the ground where all the machinery manufacturers, the top machinery manufacturers, have brought in their developments over the years. Their main focus is usually on quality, productivity, improved efficiency, power saving, and digitalization. However, what has made the last 2 or 3 ITMAs a little different is the shift from mere changes or tweaking of technology to focus more on sustainability and circularity, which is now becoming the call of the day. Now, this has given rise to a number of disruptive technologies where researchers and machinery manufacturers have put their heads together and dared to use a cliche, think outside the box. Well, there are a number of innovations that need to be understood, analyzed, and debated. I have chosen only one such technology to talk about, given the short time span, because I thought that if I talk about the others, I'll not be able to do justice to what I'm about to talk. To name some of the other things that have been done, which the manufacturers have been thinking out of the box, is the spin hole. That's a technology in spinning, where they have talked about collapsible balloon for reducing the tension on the traveler so that the spindle speed can be increased. And the other one, of course, is the helix spinning, much talked about by Toyota, where they are doing away with the ring and the traveler, and they are spinning the entire yarn in a shell. So I will not talk about all that because I'm sure that there will be others who will be coming up with that. But what has really impressed me and what I thought was probably one of the best works that has been done over the years is the innovation of waterless dyeing by, now this is waterless dyeing only of polyester by a company named Daiku. It is a Netherlands-based company. And I will just share their share most of their literature. This is what I've taken from their own brochures. So I'll start sharing my screen. Just one moment. So now Daiku is a 10-year-old Dutch scale-up that uses CO2 reclaimed from existing industrial processes to dye fabrics without any need for water. Headquartered in Wisp near Amsterdam, the company is a spin-off of Facon, a research organization that works at using CO2 to solve problems of various industries. Now, sorry. The reason why this particular thing was so important was because we felt that we have reached that tipping point where the demand on the technology has to be such that it has to be eco-friendly, it has to be responsible, the manufacturing has to be responsible. And towards that, I think I will quickly share one of the videos that I took from them. The reason why they have come up with this is like one of the biggest offenders in the chain of polluters in the textile industry is the dyeing process. Of about 300 liters of water to treat 1 kg of fabric, 75 liters or 25% goes to dyeing. This results in thousands of tons of waste water dumped from dyeing houses all over the world every year, a problem that could actually be solved by the use of this and similar innovative technologies. For these reasons, Daiku's mission is to passionately lead the textile industry to a lean and clean future. Daiku's CO2 technology is the world's first 100% water-free and process chemical-free textile processing solution, providing geographical freedom from water from water sources and offering textile manufacturers a head start on legislation that restricts the use of hazardous process chemicals. Its low operating costs allow you to elevate your short-term results and long-term ambitions, lean and clean. So basically, when you look at this particular technology with CO2, which is being commercial CO2, which is being brought in cylinders right from the industries and is being used for this particular process. For the actual dyeing process, you're not using any water at all. And since there is no water used, no water is discharged. So effluent treatment plants are something which become obsolete when you are dyeing with the supercritical carbon dioxide. Now, the technology of DYCU is well researched and proven and addresses a problem that is reaching the point of criticality, the preservation of potable water. A machine pressurizes CO2 until it becomes supercritical, which is a state in which it gains a very high solvent power. The dye dissolves in CO2 and gets transported deeply into the fabric's fibers. So when we talk about supercritical carbon dioxide, it means that carbon dioxide is at a point where it is just coming out of the gaseous form, from the liquid form into the gaseous form. It contains the, it retains the volume of the gases, whereas it also retains the performance of the liquid, which dissolves all the dyes which are being infused into this, and in turn infused into the fabric or the fiber which is being processed. Thanks to this method, there's no need for water in the dyeing process. Also, no additional chemicals are used, while as much as 98% of the dye makes it to the fabric. The machine works in a closed loop, recycling 95% of the CO2, so the whole process is close to waterless, as the 2% residual dyes can be recovered after the evaporation of the CO2. With its 130 tons of steel and pumps, the Diox is an impressive piece of equipment. It consists of 3 dye vessels, each with a loading capacity of 20 to 200 kgs, adding up to a maximum daily capacity of 4,000 kgs. The machine uses zero water, as it uses reclaimed carbon dioxide as a dye carrier. Beam dyeing process suitable for woven, jersey, and yarn. Fibers can be loaded directly into the vessel. Closed loop system, this 95% of CO2 is recycled after each batch. Uses pure dyes, no additives, hence process is chemical free. No wastewater, hence no wastewater treatment. Now 3 dyeing vessels, there's parallel dyeing, 3 separate colors. So with 3 dyeing vessels, it is possible for you to take 3 separate colors and dye them at the same time. Quick batch to batch color changes. Loading capacity 20 kg to 200 kg per vessel. Average daily capacity is 4,000 kgs. Now, the features of batch to batch repeatability, 98% dye uptake, easy raw material loading, no reduction cleaning is necessary unless a color change is required, fully automated hydraulic door handling, fully automated CO2 flush cycle, highly advanced CO2 separator for CO2 recycling, highly advanced high pressure values, reinforced proprietary CO2 sphere, custom cleaning device, MCM, mechanical cleaning machine, and dye cartridge preparation system, DCPS. Now, as far as the safety features are concerned, it can withstand more than twice the operating pressure. Certified by Veritas and Lloyds, safety valves installed, highly advanced CO2 detection systems, built-in safety stops, custom software prevents operating errors, built according to ASME standards. Now, DYCU uses patented and industrially proven technology on CO2 instead of water. So how does it work? The technology uses reclaimed CO2 as a dyeing medium in a closed loop process. When pressurized, CO2 becomes supercritical, SC CO2. In this state, CO2 has a very high solvent power, allowing the dye to dissolve easily. Thanks to the high permeability, the dyes are transported easily and deeply into the fibers, creating vibrant colors. CO2 dyeing does not need added process chemicals to dissolve dyes. The technology uses 100% pure dyes, and with more than 98% uptake, doesn't waste any of it. Zero wastewater, no process chemicals, no water, no wastewater, and therefore no wastewater treatment is necessary. The CO2 used is reclaimed from existing industrial processes, recycling 95% of it in a closed loop system. Energy efficient. CO2 dyeing is a dry process, eliminating the need to evaporate water. The addition of efficient color absorption and short batch cycles makes our technology very energy efficient. The process uses 100% pure dye stuff, giving beautiful, vibrant colors. The dye is distributed evenly over the fabric, and the technology allows for easy color correction. The dye stuff penetrates deep into the fibers, creating intense colors with excellent quality characteristics. Geographical freedom, which is probably one of the most appealing features of this particular technology. Now, dyeing without water equals geographical freedom, becoming completely independent from clean water availability. We can dye fabric in the middle of the Sahara. This opens up new opportunities for the textile industry, allowing production to occur closer to market, shorten lead times, and disconnect from Earth's most valuable resource, that is water. Now, summing up, a capacity of 4,000 kgs per day, dyeing of polyester fibers, yarns, including blended yarns to give a melange effect, and fabrics, both knitted and woven. Excellent color because of 98% dye absorption. Color fastness of 4 to 5 across all parameters. 95 to 100% dyeing efficiency. Lower recipe cost per kg of fabric because of no additives for similar dyeing results. Now, this is a point which is slightly debatable because we are used to dyeing processes which are delivering to the masses, where the dyeing fastness requirements are not so stringent. In that case, the dyeing cost is definitely lower because we are crimping. We are actually reducing the cost on the quality of dyes, the process itself, and the residuals which are left behind. So if we are to get a color fastness across all parameters of 4 to 5, we are definitely, this particular technology is definitely cheaper. Now, lower recipe cost, like I said, for similar dyeing results, the dyeing is correctable. Theoretically, it is possible to extract the entire dye from the fabric, yarn, and fibers. However, currently the machine is not designed for that work, and work is still on to achieve that. Now, this makes it very interesting in the sense that if we find that the dye, or if the customer says that they need a different dye shade, the same fabric can be reprocessed, the entire process can be gone through, and with a change in the dye colors, the entire process can be reversed. Reversed in the sense that it can give the new shade required without actually discarding any of the fabric or having to go through a very lengthy washing and re-dyeing process. Now, current dyeing cost is approximately $1 per kg. This may look very high to a lot of people, but overall, when we talk about saving the atmosphere, when we talk about saving the ecology, saving nature, this is not a price which is really worth considering. Overall, it has a 56% lower carbon footprint. Now, a lot of companies are encashing the carbon credits that they earn from this. So that does make commercial sense. But in real terms, when we talk about the health of the environment, when we talk about the health of earth, it is really not the right way to go. But nevertheless, that is part of the commercial setup at the moment. And as we go forward, probably this will be taken up and corrected the way I feel it. Now, the current price is 3.1 million euros, which would look very daunting to a lot of people. But then when we look at the entire gains that we are going to get out of it, it is going to be definitely very much in the reckoning. Now, installations and markets. There were a lot of skeptical words that I heard from people all across, that this particular, because I believe this particular video that I shared had been shared in one of the platforms, and there were lots of comments where people were saying that it is only for the lab and it is not commercially viable. For that particular clarification, I would like to tell you that there are 17 installations around the world, mostly in Taiwan, Vietnam, and Thailand, and one in Netherlands, where they are dyeing the products extensively, and the biggest markets are the brands. Because the brands are the biggest buyers, as they are concerned about their environmental positioning and responsibility. Currently, the brands that are patronizing dyed fabrics are Adidas, Puma, Nike, Reebok, IKEA, Decathlon. More are in talks with the company to help identify companies using this practice. So this was what was there about Daiku. Now, if we look, what is unfortunately happening is that we are weighing everything in monetary claims. We are weighing the well-being of a company and only in terms of the monetary returns that we are getting out of it. Now, when we talk about the health of the planet, when we talk about the health of the people who are actually inhabiting the planet, this particular cost changes its shape, its requirements, and it is now more and more critical that we start looking at this particular area where costs become secondary and health becomes primary. I have been in talk with the managing director of Daiku, and he assures me that as the volumes build up, as more and more machines come into the market, the prices of the dyeing cost will also come down. So it's something which is very much for the future, and where we have to look at the entire scenario a little differently. Just one moment. Like they say that if you have thought about it, it can be done. And there is no greater incentive for innovation than a problem needing a solution. With 2.7% potable water content in the world, pure, clean water will increasingly become a much sought after commodity.
Your slides are not visible.
No, I've stopped sharing now.
Okay, all right.
I'm only on the audio.
Okay, sure.
I'm just trying to sum up what I had presented and the need for that particular technology. So as I was saying, that with 2.7% potable water content in the world, pure clean water will increasingly become a much sought after commodity. One that, as some of the skeptics have said, that could well be the cause for the Third World War, unless we wake up to the seriousness of the situation and start working towards finding solutions, such as Daiku and Devin Supercriticals have done. Now, Devin Supercriticals is another company which is working on the same lines as Daiku, but there is a slight difference in the technology where they are still using a certain amount of water. And Devin is a homegrown company based in Bombay. So we are sure that we'll be hearing more from them. And I'm sure that they'll also be giving us a lot of inputs about the waterless dyeing and the movement towards that. So I think it is high time that we started re-evaluating our technologies for the environmental impact that they make. It is time that responsible manufacturing becomes not an exception, but a norm. Let us stop evaluating wealth in monetary terms alone and start realizing that caring and healing the earth to provide a healthier environment is not only our greatest challenge, but also the biggest wealth that we can leave behind for our future generations. Thank you.
Thank you, Mr. Kamal Misra. Thank you so much for giving us more detailed view into the new technology of dyeing. I have a lot of questions and I will start by, of course, we are going to start with the questions which have been put in the chat.
Okay.
And when we reach the end of that, I see there's a hand raised as well. I will come to you a little later. So may I start with a question on how AOP works? This is by Ajay Rudrapal. So how AOP works? This must be for Shailendra ji.
Yeah, that's right.
Yes. Yes, please. Please go ahead. Mr. Shailendra, I can't see you.
I'm here.
Oh, yes, yes,
Yeah,
yes. Please go.
I could not understand what he asking, the full form of AOP, what he asking.
Yes, so Ajay Rudrapal ji, boliye, what is AOP? What did you mean by that? Oh, I can't see. Would you like to clarify? Okay, if you are not able to come on, we will go on to the next question. This is a question on any 3D weaving and 3D warp knitting machines.
Yeah.
I think this is a question.
Yeah, basically in the 3D weavings, the software is available. Warp knitting also available. And it's the same software that Style 3D is making. So here we can use the same fabric size, structures and everything. Only we have to digitize the fabric as per our need.
All right. Any groundbreaking technology in spinning or weaving?
Spinning is not my area, so I can't tell on those things.
No, I had mentioned, I'll take up that question very briefly because I had mentioned two of the technologies that were displayed there. One was the spin hole, where they have increased the overall distance from the nip to the rig rail, whereby the balloon, which was a single balloon earlier, is now a collapsible balloon. Now, when the balloon collapses, it reduces the tension on the traveler. With the reduction in the friction between the ring and the ring traveler, the traveler burnout at a particular speed can be elevated. So the speed can be increased further without the fear of burnout of the travelers. So this was one. I'm sure that somebody will be talking about it in the next thing. Otherwise, we'll be requiring a separate thing. I have the details with me, but then it will require a lot more time. Like I said, because of the paucity of time, I chose only one subject to talk on.
Right.
The other one, which Toyota has displayed there, is Helix, where they've done away with the ring and the traveler, and they have encased the entire bobbin in a kind of a chamber where a helical movement is actually doing the spinning. It is not very clear to me. I'm sorry as far as that is concerned, but they have been quite secretive about it. I'm sure that their technology has not been discussed very much in detail. So the theory is not very well known, at least not to me. I'm sure that somebody from Toyota will be able to shed more light on that. But yes, it is something which is still to come into the market. Probably at the next, before the next ITMA, they will be launching the machine. Up till now, it has not been launched commercially.
Thank you, sir. I think there was a question on fastness of the embroidery threads, which has been answered by Shailendra ji. So I'm moving on to the next one. Please explain what is GSM and CPI. This is by Sonali Kumari.
Yeah, basically GSM means grams per square meter. That's how we weigh the fabric. We calculate the quality of the fabric. And CPI means course per inch. That's the number of loops in an inch. Yeah.
Right. So thank you. Thank you. This system. All right. I'm moving on to, I'm just wondering whether there are any more questions. Has any Oikotex testing done on carbon CO2 dyed fabric?
That
Mr.
that I'll have to check up and come back to you. But they have been, since they are already being patronized by the brands, I'm sure that they are totally compliant in all those areas.
Right. Thank you. A question from Reena Pavitran. Daiku saves water, but works only on polyester fibers. How do they calculate whether by saving water they are using microfibers that pollute that very water?
Come again,
So
the
Daiku
question is-
saves water,
yeah.
but it's done only on polyester fibers.
Yes.
Whereas the microfibers in that polyester fibers are polluting the water. So how is it more sustainable?
No, there's no water being used at all. This is the selling point of that particular technology. So the point of microfibers polluting the water does not come into play here. Number one. Number two, when we talk about the process, it's not that it is totally water free, but then there's a lot less water used because only the scouring of the fabric is done separately. And with polyester, they can even do the scouring in CO2 itself.
Right.
What comes out is a totally dry fabric, so no water is required there either. And as far as this particular question of the technology being used only for dyeing of polyester, there's a lot of work being done in other areas as well, where they are also working on acetate fibers at the moment. They are also talking about dyeing natural fibers. And the only problem there is that it is triazine, fluorotriazine dyes which are being used for dyeing cotton. But I think that acceptability is an issue, and they're looking at different methods of dyeing the cotton and the other natural fibers, and they'll come up eventually. If they have reached this far, I'm sure they'll be able to take it much further.
Right. So thank you. I have some few more questions, but I'm going to move on to Dr. Swapneshu Basar. May I request you to switch on unmute yourself and please start. Yes.
Good evening, everybody. And good evening, Mishra ji.
Good evening.
I'm Dr. Basir from Devin Supercriticals. We
Yeah,
have this technology called Supra Uno,
right.
which is an indigenous technology. And let me say that we have a bigger edge over Dyco technology in terms of being already able to dye not only polyester, but we can dye cotton, nylon, acrylic, polyester cotton blends, wool, etc. And we don't use any special dyes. We are using conventional dyes, conventional trichrome recipe with supercritical carbon dioxide. So this is something which we have been able to achieve. We have got a patent in India as well as in USA for our process. And we have done a lot of trials. We have a prototype plant in Mumbai. So we welcome everybody to visit us, see the samples, what we have done. And I would be really happy. We had also been participating in ITMA 2023 in Hall 11. Our stall was B305B. I request the organizers to give us a chance to also present our technology, which was presented in ITMA 2023, so that, you know, our Indian answer to the world and having a unique features can be explained in detail. The only thing, Mishra ji, with I would say is both the technologies, Dyco also requires a washing after dyeing, which they have also given in their presentation. So it is slightly not correct to say that they don't require any water or microfibers will not go. But the amount of chemicals which will come in washing in our process and their process also will be much less. So the post treatment will be much less. I would say that when we do cotton and cotton polyester blends, we don't require any salt. So we have a completely saltless process. We don't do any reduction clearing. We do one-step process for polyester cotton. rather than two-step process. So rather than taking 10 to 12 hours in conventional process, we take in 1.5 hours to 2 hours. And yeah.
Sorry,
Dr.
thank
Bishop.
you. I'm going to just move, since the time is very limited, there's one question which is related to this. The question by is waterless dye fully consumed, or there is some waste generated? So of course, I guess there is some answer to that. Is there any technology for the waste?
If I have to answer, I can say that there is some amount of unfixed dye, even if it is 2, 3, 4%, and that will go to the water when you wash it. But as I said, for cotton, when we don't use any salt and we don't do any reduction clearing, I think we use around 90% less chemicals overall as compared to exhaust process. And that, for zero liquid discharge will reduce a huge amount of load on the zero liquid discharge plant, which may be required by the company.
Thank you. Thank you.
Dr. Besar, I was there at the ITMA, and I'm really sorry that I was not able to visit your stall. It was brought to my notice by Casper, the MD of Daiku, and I had actually met them in 2015 the first time, and that is why it was there at the back of my mind. I never knew that any company in India was working on the same lines. Of course,
so in relation to that, there's another question, if I may
Yes.
put it. Currently, is there any company in India using Daiku dyeing system? But if that's a question which can be answered shortly, and then of course there is Dr. Bashar's company as well. So
yeah, at the moment there is no company in India which is using Daiku dyeing systems.
okay.
Yeah.
2 more questions, then we can perhaps look at winding up.
Yeah.
Raj Pandey is asking, what's this new spin hole technology in spinning? Is it an extension of ring frame spinning?
Yeah, it is a modification of ring frame with some additional attachments, where the overall distance between the top arm and the nip from where the cotton is actually coming out to the ring rail, that distance is increased. And in the process, the increasing, because the spindle size remains the same, the entire ring rail is in relation to the top arm, the ring rail distance has gone much lower. So, or rather the top arm has gone higher. The balloon collapses in between. There are multiple balloons which are formed by the collapsing of the major balloon, which reduces the tension on the traveler. It's not it's not a separate machine. It's a modification of one of the existing machines.
Right, thank you. So I'm going to end this session with a question from Shailendra. Shailendra Nigam, the one who's presented first, is the last to ask a question. Can we use this system on any dyeing machine?
The dyeing plant itself is entirely different, and I'm sure Dr. Besar can shed more light on that, since he's from the same field. I'm basically a spinner. I just happen to catch this particular technology. It just caught my eye, and that is why I chased it up. Otherwise, I'm a total greenhorn when it comes to dyeing. So, Dr. Besar, if you can please answer that question.
Sure. Thank you, sir. Basically, this is a different technology, as Mishraji said. Basically, we go to supercritical conditions for carbon dioxide to have solubility of the dye. So we have to go above critical pressure of the carbon dioxide. So because the pressures are typically in the range of around 200 bars, so we will require a special machine for dyeing of this with this technology, as compared to our conventional machines, which may run maximum 3 to 4 bars.
Right. Thank you very much, sir.